Okay, next up we have Mingwei Hu.
Hi everyone. My name is Mingwei, and I'm working with Donna Cox and Stuart Leavitt. So my project is about integration of Virtual Director and YT, which is a software render. So a brief introduction. Virtual Director is developed here and is basically a software interface that provides motion capture functionality and also the navigation control. And it also provides a choreography data that is serving for rendering the astronomical data files. So our work is to use YT's rendering power to render the data file from the virtual director. But one of the challenges is that we currently we lack a system or model to make YT run efficiently. So I came up with a model called ventilator and worker and sink. It's basically a parallel processing model that can run different tests at the same time and in parallel. So I use a library called 0MQ to implement this model. It basically enables a ventilator that distributed different tests to multiple YT workers, which is a software instance that runs on different machine, and it could also runs on the same machine. So the best thing about this model is that the ventilator doesn't need to know where those workers are, and because the whole system is aimed to be dynamic, which means there could be workers joining and quitting at any time, and which shouldn't interrupt the whole process. So we implement this model that uses the socket, which is asynchronous. This is different from the traditional network socket because in traditional network socket, if a sender sends something and there's no receiver, and the package would possibly be lost. But in this 0MQ model, we have this asynchronous model where the message sent will be queued on the underneath layer. So even though there is no receiver available, the message will not be lost. So this is pretty suitable for our case because we need to have different YT workers to join and quit at any times. So this model is basically parallel, and then we have different YT instances running on different computers. And I have a result. Is basically I measure the rendering time to render different number of images. So as you can see, as the number of worker increases, and for the same number of jobs, the rendering time actually decreases, and they follow a similar trend. And then it's pretty clear that as the number of tasks increase, and the amount of rendering time will increase accordingly. But the general trend is that when number of workers increases, the time spending on the rendering will decrease. So which means this model indeed increase the efficiency of the rendering process. Yeah, I think that's it.
Can you put your last slide back up? I'm just trying to understand it. Thank you.
There's actually an arrow point there. Like if you can see the point very high up there, I think it's actually because when I test the rendering process, I actually accidentally run a browser instance that may cause some CPU consumption. So that's one of the error. But the general trend is with the number of workers increase, the efficiency will increase accordingly.
So, and why isn't it a smoother line? Like, why? Where is the overhead coming? I mean, you'd expect 4 workers to be.
I expect it to be lower, smaller than. So actually, I have 8 jobs there. It's supposed to be quicker than the 10 jobs, but it's actually higher. So I believe it's because of an error happening there.
Were the workers all on different machines, or did you have some machines that had multiple workers?
I have one machine have multiple workers, and another machine have multiple workers. So just not all different. So some are running on the same machine.
Okay.
But the ventilator doesn't need to know where the IP address is. Because
Which piece finds which other piece? When the worker starts up, is it told how to find the ventilator, or the ventilator knows how to find
the worker needs to know the ventilator's IP address, because the ventilator is acting as a server that binds to a IP address. So that function, it needs to receive messages from the workers, and so basically the worker needs to connect to the ventilator. So he only needs to know the ventilator's IP address, but not vice versa.
Cool.
Thank you.